technical interview is unlike any other job interview. It's a tough and rigorous process that tests your coding skills, problem-solving abilities, and personality. But it can get a lot easier if you're well prepared and know what to expect. Join Interview Kickstart's co-founder, Ryan Vallis, in a 1-hour interactive webinar on how you can crack technical interviews at top tech firms the Interview Kickstart way. We have helped over 5,000 engineers receive life-changing offers from FANG and Tier 1 tech companies in the US. Your dream company is just one step away. Sign up for a webinar today.
Let's do this. Do you want to share a Google Doc or whatever? You might have to mostly write and draw. I don't, I mean, you can share your screen. Yes, that is perfect.
Sounds good.
So let's do this. So what we want to do is we want to build a search relevance system, right? So search relevance.
Okay.
And, yeah.
Sounds good. So I have a few questions to understand the scoping and the scale of the system. Are we talking more of a general search engine, such as Google, or something with regard to, let's say, like Twitter search or Amazon, where we search for products?
Yeah. Okay. Good question. It's Google.
Google.
General
okay. So. Sounds good. And then with regard to personalization, should I assume that a user might be logged in?
This is for a logged in user. Yes.
Got it. And I'm assuming we need to serve the whole global world, right? It's not a specific place that we're targeting.
Yeah, whole world.
Sounds good. So the way that I would approach this system is we want to see, the way that I would translate this system into an ML question or an ML problem that I'm going to solve is I would like to build a system or an ML system that generates the top, let's say, top 100 search documents in the World Wide Web that are ranked by relevance. And by relevance, I would mean that we want to see that it's both relevant to the query and to the user, so personalized. So this is the rephrasing of what I'm looking to build here. And my next step for me would be to identify in a high level what is the goal of the system. Are we looking to increase engagement, click-through rates? Is there a specific goal that you would like me to focus on?
What are the goals that you can focus on?
Well, so basically what I would expect if I were Google is I want to see that the top results are the ones that are the most interesting to the user. So basically, I would say click number of clicks for top 10 results, let's say. What else? I would want to see that if there is a lot of irrelevant documents that are coming up in the top 10, then I want to be able to measure these as well. So I would probably see I would also want to count number of impressions. So basically impressions would probably, given that this is a classification problem to begin with, before I go to the ranking, I would expect to see here a positive and a negative class. The positive class would probably be a combination of the clicks, and then the negative one would be the impressions. Another way for me to assess a negative class would probably be the amount of time that a user is spending on the search engine. But if I would, in a very high level, number of clicks would show me a successful result, and the number of impressions less successful. And I see that there is going to be some imbalance. Essentially, if I'm assuming most of the people are heavy Google users, but usually when I search for a query on Google search, I'm not going into, and I see the top 10 in the first page, I'm not going into each and every query in the top 10. So I would usually navigate into 1, 2, or 3 queries top. So I would probably have here some imbalance between the positive and the negative classes. So I'll just say, so negative would be number of impressions, and positive would be number of clicks per document. And then, okay, so let's see what else I could do. If I were to think through what is the data that I would feed into the system, maybe I could use a combination of both an online and offline data. So if I were to think about the data collection piece, I could use some offline data collection, such as, let's see, I could use human raters or human labels that would let me know. One thing that I haven't mentioned, I would probably want to optimize for NGC. Okay, so where was I? I could use some human raters that would let me know what is the effectiveness of a search. And I could, but there's a trade-off of the cost. It takes a long time and it costs a lot to gather that information. So a better way for me would probably to do online based on users' engagement. I also want to make sure that I'm able to, I'll get to that later, but I'll just put here in, I want to make sure that I'm not surfacing anything that includes bad language, hate speech. So I would probably have some kind of a mechanism to classify such documents and make sure that I remove them. And I would want to also, yeah, so this is in a high level. But so before I go into the feature engineering and what is the data that I'm looking to process in the system, in a very high level, I would say, let's say that there's a user that is searching online for some query. Then I want to do some tokenizer that would help me to analyze the main entities in the query and also some context. I could also use some external data set or embeddings, such as Word2Vec. So let's say that I use that. And so I would feed whatever I read from the Tokenizer and the word2vec embeddings into some system that would do some feature pre-processing, where I will essentially work on normalizing the data, creating all the features. And I will talk more about that soon, but creating all the features and all the data that would be fed into the model. Once I'm able to do that, since Google has so many documents, I would say hundreds of millions or billions of documents, I would want to do some classification, and probably try to be able to predict the top 1,000 documents. Not predict, what is a better word for this? Find the top 1,000 documents most relevant. And then once I have that, as I mentioned, I want to see that I'm classifying, that I'm not selecting all the documents that are having bad language or hate speech. So I could, let's call this, remove all bad documents. So all the ones that have, and I will use probably classification, binary classification for that.
Mm-hmm.
And once I have that, I have up to 1,000 documents now. I would want to do the ranking so that I could provide ranking top 100 documents sorted by relevance. Now, one of the things that I also want to make sure is, let's say that the user, and so this is the output. This is the output of the system. So let's say that I have all the results, search results, output. Now the user is engaging with those. So I want to, based on the user's interaction with those search results, I want to be able to feed that data into the system. So maybe so based on the user's interaction with the system, I would feed that data back into the feature processing so that the next classification and also the next ranking will be taking into account whatever the user was doing. So this would be fed both into here and into there. So that's in a high level, how I would approach this. And then the next step for me would be to understand, okay. The next step for me would be to understand how I would select all the features here. So with regard to data selection, let's see, I have all the user-based data, which will be user interests, everything we captured from previous searches. I have user demographics, which is age, gender, location, location, etc. I would have the user's previous engagement. I would also want to feed into the system. So I guess some users, this is mainly the user-based data. I could also have the domain-based data. So the URL, which is a sparse, which hints me towards seeing how I can use a model that could handle sparse data. I could have previous engagement, an aggregate number of clicks, number of impressions, etc. I could have some embeddings for the context of the document. And then for the user's interest, it's also probably going to be in the form of embeddings. So I could use some additional pre-processing work to create these embeddings for the user and for the document. What else? I want to see also similar users that interacted with the document will also signal to me whether there is a high chance of the user interacting with the document. Some more context-based features such as day of the week. If there's, let's say, season or holiday, there's location. Maybe there is some trending news that are relevant that I want to feed into the system. So maybe in the form of embedding, I could have that as well. Let me think about other features that could be interesting here. Basically, maybe also users' interactions with similar documents. So if a user was interacting with a document that is that has a high similarity with that specific domain, then I could also feed this into the model to understand more whether the user is likely to click on that specific document or not. And then, once I do the data selection, I will need to understand how I classify all the top 1,000 documents that are most relevant. Given that Google search really needs to output the results pretty quickly, I would want to see that I'm able to do it within a few milliseconds. So let's see what I have here. One way, so that's on one hand, they have the option of doing logistic regression for a binary classifier that will help me to find the top 1,000 documents really quickly. On the other hand, I would want to see how I could combine that with some online learning to output the top documents that also take into account the user's interests. So I could do multiple steps here. For the binary classification of top 1,000, I could use logistic regression. This should be pretty simple. And then for personalizing and ranking this, one way I could do is I could do some divide the documents by entities, and then I could do some offline ranking to generate some features to the models that will be fed into some online training method that will be able to calculate the ranking pretty quickly, that takes also into account the user's past interests. So I could use some, were you saying something?
No, that's reasonable.
So I could use some offline model that what I want to do is that offline. So first of all, before I have a few steps. The first steps I have a few models. One would generate embeddings for the user. One would generate embeddings for the document. And they could use neural networks for that, given that I also have a really imbalance in the classes and a lot of different dimensions here. I feel like I could use offline learning using, using neural networks. And then those models will, in an online setting, will be fed into a ranking model. And that ranking model, I could again use some logistic regression to rank the top 100 documents. So basically, let's see. So this would be logistic regression. I also have an offline model that generates embeddings that these will be fed into the ranker, and based on the user's interaction, I'm still new to that specific board, I'm not used to it. Based on the user's interactions, I can feed it into the embeddings. That will be fed into the logistic regression that will output to me the top 100 documents. And then let's see what else I need to. So basically what I want to do is for the, now the way that I want to tune those models, first of all, the binary classification of top 1,000 model documents, I want to make sure that the amount of true positives, let's see, I have two options. either to optimize for recall or for precision. And given that we have a really imbalance of the classes, I would assume that it's going to be about 20 to 80, so 20% of the, or even less, like 1% of the data will be only positive classes. So, or 1 or 2 or 3%, because actually, usually when I am looking through Google, I only click on 1, 2, or 3 top relevant results. And so out of those 100 results, I would only have, and then I would also, one thing I haven't mentioned, I would want to see that I weight, no, yeah, never mind. I want to see that I put some weight into how many times, yeah, but I captured this in the previous engagements, actually. Okay, so basically, I would want to optimize here for recall out of all the actual documents that are the most closely related to the query. I want to make sure that I output the maximum documents. And then in the ranking, I would want to optimize for precision, maybe, given that I want to maximize the amount of positives out of the predicted positives. Oh, I haven't discussed that piece, but I could go into that later. But yeah, so what I would do is, given that these embeddings will be the inputs to those 2 logistic regression models, I can do some, let's see. I can do some tuning. I can't do tuning on the fly, but given that I have so many searches a day, I would expect to be able to learn. So yeah, I actually should be able to do some. So for a specific user, so there's the user-based data, and there's the domain-based data, and then there's the context. I can do offline hyper tuning for the logistic regression models to understand what is the data that I want to select for these models, so that I could avoid situations such as overfitting. So I would do offline experiments to increase or decrease the weights that will be ingested into different features, either the user-based or the domain-based. And that's how I can make sure that the logistic regression models that are running online when the user is searching would provide the best results, and I can do some data selection based on that. So this will help to tune the online models. And then, yeah, I could always do some L1 and L2 regularizations L1 to do some feature selection, avoid overfitting in L2 because I want to see if there's some collinearity in the features that are inputted into the model, and there could definitely be. Then I want to make sure that I avoid such issues. So I could do a combination of both L1 and L2. And I could also decide on the fly. But basically, if I have the training data set and the validation data set, I could do these offline experiments, tune the features, and based on that, run the models. And then in order to evaluate, so as I mentioned, it's going to be recall for the first one, then for the neural networks. Yeah, and see. And then for this ranker, I could do, I could try to see how I can optimize for precision. And this is what I would target in order to tune the parameters of the models. The one thing I'm still thinking about is whether the training takes place after the user put the query. I would assume that maybe it would be a tool of a high latency, but I'm not 100% sure. Mm-hmm. So in case it is a high latency, I mean, you know, in your magnitude of a few seconds, I definitely want to avoid that. So if that's the case, one way for me to do so is to run some offline, I mean, to do it offline, and then the evaluation will take place in real time. So I could do the ranker, introduce some weights for each and every document, for each and every user. So let's say that I have like an embedding for each and every user, and I have an embedding for each and every document, and then I have a ranker that runs based on these. I could do an online evaluation. So all the models will be running offline. So not all the models are running offline, but the logistic regression of the ranker can run, can be triggered with every user's actions, because those previous engagements, I want them to be taken into account by the next time that the user is searching for a query. And so I could run this logistic regression in an online manner, the training, introduce some weights, and then by the time that the user is searching for that specific query, then I could apply those weights and evaluate in real time so that I can output the best results.
Mm-hmm. After, so let's see this, like, do you think you would want multiple stages, or do you think of a single stage?
Well, in the offline training, I would want multiple stages. I would first, I would want multiple stages for the offline, but for the online, there's only one stage of the.
So your classification to find the top 1,000 documents is stage 1 or stage 2? Like, let's assume 2 stages, maybe to start with.
Well, that would be stage 1, but
okay, that makes sense.
And then stage 2 would be offline to rank or create the embeddings for all the documents and for all the users. And then stage 3 would be to generate some scoring mechanism so that in an online setting or in real time, we're able to output the top 100. So I would possibly want to give, let's say that we have a big matrix. I would want to put a score for each document cross user, so that then I could output the top 100. Now, given that I'm not able to do this for each and every user, for each and every document, since there are billions of documents and billions of users, or a few hundred millions, I would probably not do this for each and every user, but I would do it for only users that have searched for the relevant query. I would put such a score, and if there isn't a score because the user hasn't searched for a relevant query, then I could look for a similar query or a similar group of documents, and based on that, I can try to assume. And another option for me would be to just provide the general. So let's say that I don't have any information about the user in that specific query. It's the first time that the user is searching for such specific query. Then I would output the generalized ranking of those documents, and then the user, and based on the user's interaction, I would be able in the future searches provide a more personalized result.
Okay. What are the other problems you can get during offline training?
Other problems during offline training? Well, first of all, the size of the data is massive. So I would need to see whether I should be able to use, I probably would need to shard across multiple servers to create those models, and then aggregate the results to output a score. What else could be wrong with the offline training? It's a pretty complex problem. So I want to make sure that, so I guess that if I see that it doesn't make sense to run all these models, especially the neural network models, for all the documents and for all the users, maybe I can do some kind of a hybrid approach, or no, wait, I do want to do. I could possibly think through some way to do a hybrid approach of both decision trees and neural networks, or either or only one, based on the capacity and the cost of the system, and how much it can generate. Those are the main things. I would probably want to do some replication to see that the system is fault tolerant. Yeah. And one thing I also haven't mentioned is that I want to see, maybe I would need to do another stage here before I output the results. I mean, I want to make sure that the results are not all talking about the exact same thing. So for instance, if I have multiple websites for Stanford and I'm looking for, and my search query includes Stanford, I want to make sure that not all of the results are the Stanford domain, but diverse domains. So I would probably want to put some weight into that when I generate the results.
Mm-hmm. What are the other problems you can see during online training? Like, just talk about, basically I want to see, let's say during your work as an ML engineer, what were your top challenges? Like if you were building this, what would you be worried about?
So during online training, I would expect to see a lot of requests coming in per second. So I want to make sure that I have enough compute servers that could provide me with the output. So this is one thing I want to do. And that the load on the system doesn't mean that I'm not able to provide the right results. And so I need to see how much I shard to different compute servers.
So suppose, let's say you're offline, during your offline training, what metric are you using for your offline training? Did you did like online is your CTR, right? Offline, what was it?
For the offline training, I mean, I could use some precision and recall to understand the accuracies of the model. I could use some AUC.
Yeah. Okay. So
Mm,
let's say AUC says this is a great model, and you launch it, and online training shows that it's not a good model. Like the CTR is not good. What are the causes for that? Potential, like
well,
one or
yeah.
two causes.
So a few options here is that the data selection method is not good enough. I might be overfitting the model as well. I also I might. So you were saying the offline show good results, but the online are not good, right?
That's right. Offline
Yeah,
is amazing. You see that.
I might have some data leakage, so I need to check for that. And then yeah, so I would need to go back to the models and do hyper tuning in every once in a while to check that the models are calibrated. I want to see that I don't have any bias in the model. So I would probably track both the online and offline metrics, and based on that, trigger some hyper tuning on the fly, and rerun the models based on those new hyper parameters. I haven't mentioned that I would always be able to do some A/B testing to understand also the effectiveness of the models in order to, the end-to-end of the models. So this is a way for me to evaluate online.
Okay. And let's, yeah, I think that makes sense. Yeah. Now, as part of your development, talk about what are the development tools that you used, like especially around your model development. Like what language did you use? What tools did you use? And
so I I mean, I need to use to take advantage of Spark and Hadoop and use maybe TensorFlow for the neural networks, NumPy and Panda. So I could use Python, use Scala for the data, for the feature engineering piece on Databricks.
Mm-hmm.
Yeah, these mainly HDFS.
Mm-hmm. And talk about what were your challenges, like any developer productivity issues that you had? Like you say, hey, this could have been better. Like it's bothering me. Right.
Well, first of all, I want to see that I'm able to output the results in a timely manner, so within a few hundred milliseconds.
Mm-hmm.
So I will track that for sure.
Mm-hmm.
I will track to see if I have some hotspots in some locations in the world, and maybe I need to divide the load differently and do some more and allocate some more servers in some places. What else? I could use some additional, I mean, I would always need to track for any error that takes place, of course. So I would need to have an alert system that tells me that there's an error and allocate someone to take care of on-call duties such as that. I would probably put some threshold. So if I have X models that are beneath some threshold, I would need someone to debug and see what's going on. Maybe there's, something really serious going in the world and therefore everything is biased. Then we need to do some quick work to tune the models.
Okay. Awesome. We are pretty much out of time. What do you think? How did you do?
Well, this is my second mock interview. So the first one, I wasn't very structured. So I feel like the structure was better this time.
Yeah.
But I felt that I would have wanted to understand more the latencies to see that I am able to output the results within a few hundred milliseconds.
Okay. Yeah, I think scale you could talk about, but none of that is like really scary, right? Like, because most of the time the interviewer would ask you further questions. If you do not bring it up, it's not a very dangerous thing.
Okay.
So it's okay. You don't have to worry about, did I bring everything up? Like, the main thing is, if the interviewer asks, then you probably have to be able to answer it.
Okay.
Then I think the biggest thing is a lot of people are, there are only limited set of questions, right? Like, most people know what questions are there.
Yeah.
So in this industry, at least for ML engineering, the questions are always going to be known. Everybody knows the kind of questions. Like, they won't be a random question somebody will ask you. It's all about relevance or, some of the common problems that you have in machine learning. I think the bigger thing is you need to bring your personal experience as part of your working. Like, you as an ML engineer, people will try to deep dive on how much you know theory versus how much you know actually practically.
Got it.
Right? That is what will differentiate you from other engineers.
Yeah.
Because theory everybody knows. Whoever I asked, actually they went through similar thing. Because everybody knows these are the things. I need to do logistic regression. I need to do feature selection. I need to do all this regularization, AUC. So those are things everybody knows. But the point is, how much do you actually practically know is what you have to show. So, and it doesn't necessarily mean you need to know practically exactly this problem. It is possible you are a specialist in some other kind of machine learning. Like, you don't need to know neural nets. You need, even if it is pure logistic regression or any you need to know exactly end to end what challenges you had, and you need to bring that up as well. Like, hey, I might do this, but here are the challenges that might get into. But you don't have to be very specific to this problem. You can say, in the past, I saw these problems, and this is, do you want me to go into that and all? But most likely the interviewer will ask you. But remember, a lot of it is not about how you answer this problem, but how you're able to answer follow-up questions is more important than even if you're not structured, you'll not fail. That's what I'm saying.
Got it. Okay.
Because you will get that as a question. So don't worry. So focus more on how deep can I answer the question when it comes, because that will show your seniority.
Got it. Okay.
So that would be the more focus. Like, structuring is amazing. I think overall you did pretty well. Like, you were pretty much self-driven. You knew the structure as well. So that actually makes things much more easier. Otherwise, focus more on structure and the interviewers can't get more signals, right? So now, at least, given the fact that you were very structured, it made easy to understand what questions to ask as well. So I could probably get signals. Yeah, but I think you did well. Follow the structure, but remember, it will be a lot of questions that you will get, and you don't have to worry about answering because you might not be an expert in search relevance. You might be an expert in maybe vision, computer vision.
Yeah.
Right. So that doesn't necessarily mean if you can't answer this, that's a failure.
Yeah.
Right.
Got it.
Because you might have some specialization, but remember, you pull your experience out of that and then bring it up here. Like, hey, we'll do some classification, but I have not done this in the past. Here is what I had during my work I did, and I might be worried about these two problems, or this is what I will do. Show your practical experience as part of the discussion.
Got it. Okay, sounds good. I'll make sure to highlight that.
Awesome. That's all I had. I think you did pretty well. I'm okay with that.
Okay, thank you so much.
Yes,
thank you very much.
Yeah, I wish you the best.
Thank you. Have a great evening.
You too.